another example. So here we've got x squared times the sign of something. So this is going to be product rule first, but this sign has a 5x cubed in the argument, so there's going to be a chain rule in there too. But notice we're looking at sort of the outside of the whole form of the thing, that you've got a product here first. So if I do my derivative, I'm going to have this times the derivative of this sign plus the sign times the derivative of whatever that other function was, x squared, right? Okay, so I've got x squared. Now when I take the derivative of the sine function here, remember I've got that argument in there, so I'm using the chain rule. The derivative of sine is cosine, so I've got cosine of what's inside the parentheses times the derivative of what's inside the parentheses. And then this one is just here, and my derivative is just 2x. Okay, so this guy, the derivative is 15x squared. So I could write the whole thing as another line, but maybe I'm just going to try to think about that's 15x squared. Let's put it together. This is going to be 15x to the 4th cosine of 5x cubed plus 2x sine of 5x cubed. Okay, so notice that it's not going to be just like the derivative of that or whatever. No, you have to use the product rule. It's in there. All right. Now here's another one that maybe people do find a little bit tricky. It's secant being our outside function. So I do want to mention this because this is something that people tend to mess up a little. So remember, so here my outside function is secant and my inside function is this 4x squared minus 9. But remember, what we have is the derivative of secant of x is secant x tangent x. So if I really want to think about this as the derivative of u, it's going to be secant u tangent u, meaning that this whole thing goes into each of those x's. Okay, so whatever the derivative formula is, and we'll see in a little while we'll get even more complicated ones. We've got inverse tangents and inverse sines and stuff that we'll learn later. But as the derivative formulas become more complicated, there may be more than one x involved or one u involved. So you have to put that thing into everything. So if I do this, my outside function is secant. I'm using this. So I should have secant of whatever my u is, tangent of that u times the derivative of that u that was the thing in parentheses, right? So this derivative is just going to be 8x, right? So my answer should be 8x times the secant of 4x squared minus 9 tangent of 4x squared minus 9. Okay, so each of these we've actually done. I've used the chain rule one time. We've used the chain rule with the product rule. We've used the chain rule with the quotient rule. But we can also sort of use the chain rule again and again and again. So, for example, if I have something like this, okay, so like, oh, what is that awfulness, right? So let us rewrite this first with powers. Okay, so you see there's actually 3 different powers. Okay, So I'm going to have to use this chain rule 3 times. So my very outside one is going to be 1/2, and then it's everything on the inside of the first parentheses to the negative 1/2 times the derivative of everything that's in that first parentheses. All right. I need a bigger board, you guys. All right. Okay, now the derivative of this, notice this 1/2 is just on this, so this is just going to be 1 plus. Now I'm going to do the derivative of this bit. Okay, so this is again a chain rule. I've got 1/2 times these parentheses, x plus x to the 1/2 to the negative 1/2 times the derivative of what's in those parentheses. All right. All right. Oh, I really am out of space. All right. Well, let's just try to make it through. You guys should write this on your own paper so you see what's going on, not just watch me write it on my blackboard, which is too small. Okay. So now I've got this 1 plus. All right, this is just going to be 1 over 2 square root of x plus root x, right? And now, this last part, I mercifully don't need a chain rule for this one, right? Because I don't have everything to the power. This is just 1 plus this guy, so it would be 1 plus 1/2 x to the negative 1/2, right? And I should clean that up. We can't really see it. So let me put it up here. I hate it when when I have to do it this way. But what I end up with this is going to be 1, what's the easiest way to do this? 1 plus 1 over this bit plus that times that, so 1 over 4 root x times root x plus root x. Again, you could have just left it like down here. Okay, so just keeping it straight, just going from 1 to 1 to next to next to next is the right way to do it. Let me do one more, which is only a 2 chain rule 1, not a 3 chain rule 1 like this one. Wait, 1, 2, 3, right? Well, really only 2. But let me do one, but it has some trig functions in it. So let's do one last problem. It might be a little bit easier to follow now that I think about it, even though it has trig functions in it, because as all the square root of x's became a little bit complicated because it was like all the same numbers. So let's do here. This one, 1 plus cosine cubed of x to the 4. Okay, so this one is actually now maybe not as bad. Maybe I should have started with this one. Sorry, guys. So the outside function is the x to the 4th, so I have this 1 plus cosine cubed x to the 3rd, and then I'm taking the derivative of 1 plus cosine cubed x. What's cosine cubed x? Is cosine x quantity cubed, right? So when I take the derivative here, the derivative of 1 is just 0. The derivative of this, though, again, I have to use the chain rule. So I'm going to have 0 plus, I'm not going to write it, I'm going to have 3 times the cosine of x quantity squared times the derivative of what's inside the parentheses which is cosine of x. So I don't want to forget that here's a chain rule as well. So when I put all this stuff together, right, that's cosine. So I end up with 12. Derivative of cosine is negative sine. So negative sine x cosine squared x times 1 plus cosine cubed x cubed. So that somehow, even though it's got cosines and sines, ended up being a little bit friendlier than the one with all those 1/2s.